So question 20, solve the inequality as shown below. So we're going to first of all expand these brackets by multiplying out. So x times 2x is 2x squared, and then x times 3 is 3x, so that's plus 3x, and that has to be greater than 20. So this is quadratic, and we're going to subtract 20 from both sides of this inequality, and that will allow us to write it as 2x squared plus 3x minus 20 is greater than 0. Now, because we've got it equal to 0 or greater than 0, we can now factorise in the normal method to solve this inequality. Now, there's lots of different ways of doing this. We could do the AC method, but because we've got 2x squared, if I imagine two brackets that are next to each other, the starting point has got to be 2x and x. It's the only combination of factors that multiply together to make 2x squared. And so there's a slightly quicker way than doing the AC method here. We can just list our factors of 20. So we could do 2 times 10, or we could do 4 times 5. We could also have 1 times 20. And I'm just thinking, if I imagine expanding out these double brackets, I'm going to get 2x times a term over here, and I'm going to get x times a term here, and those need to add up to the plus 3x in the middle of this quadratic. So I can quickly see that if I do 2 times 4, I'll get 8, and if I do x times 5, I'll get 5, and if I subtract those away from each other, 8 subtract 5 will give us 3. So the 5 is going to be placed here, so that x times 5 will make 5x, and the 4 here to make the 8x, and I want a positive 3 answer. So I'm going to start with a positive 8x to do 2x times the 4, and then I'm going to subtract that 5x to get the plus 3x that is required. So I've almost solved this inequality, but we need to sketch it. So we've definitely got a quadratic curve that looks like this because we've got a positive x squared coefficient, and we know that the roots are going to be the solutions to these two brackets. So if we imagine that those brackets were equal 0 here, we would say that x is equal to 5 over 2, or x is equal to negative 4. So they would be our roots on the quadratic there. So our y-axis is actually going to be somewhere in the middle of this. And so the entire quadratic needs to be greater than 0, which means that we're interested in these shaded regions here where the graph is above the x-axis, where the y function is greater than 0. So you can clearly see that we want x to be smaller than minus 4, and we want x to be greater than 5 over 2, and that's the solution that we're going to need to write down. X will be smaller than minus 4, and x will be greater than 5 over 2 there for your final mark.